Hi again, everyone. In this video, we're going to learn to solve equations. So our standard is really two-step equations, and our I can statement has to do with two-step real-world and mathematical problems, solving two-step real-world and mathematical problems and equations using rational numbers. In this video, we're going to talk about one-step equations with certain operations. We're going to build to both this standard and this I can statement. So we're going to start off with a little introduction. I'm sure we've all seen one of these before, probably in science class. Balance, right? An equation is just like a balance. An equation shows that two things are equal. So an equation uses an equal sign to show that they're equal. This balance shows equality when these two sides are level. Okay, so I want you to imagine that this balance is level. Okay, let's say we add 5 pounds. So we add 5 pounds to this side only. What's going to happen with our balance? Well, this side is going to go down, right? And this side is going to go up. It's no longer in balance. It's no longer equal. However, what if I add 5 pounds to this side, just like I added 5 pounds over here? What happens? I think we all know it's going to stay balanced. It's going to stay level. It's going to stay equal. So adding the same amount to both sides of this balance doesn't really change anything. Keeps it equal, keeps it balanced. All right? Just the same applies with an equation. If you add the same exact number to both sides of the equal sign, the equation is still balanced, it's still equal. On the flip side, let's pretend we subtract, we get rid of, we take weight off of this side. Let's say we take off 10 pounds on this side. This side is now lighter. This side goes up. This side goes down, right? Now, let's change things a little bit. Think about how I could keep it balanced. If I subtract 10 pounds from this side, how could I keep this balanced? I hope you're thinking, well, just subtract 10 pounds from the other side, and that will keep it balanced. If I subtract the exact same amount on each side, then the balance stays level. Similar in an equation, if you subtract the exact same amount on both sides of the equation, your equation stays equal, stays balanced. Okay, so just remember, an equation is like a balance. It just shows equality on two sides. In the equation, it's on each side of the equal sign. So we have a goal when we're solving equations. When we say solve an equation, the goal, what that really means is we're trying to get the variable by itself. I put rectangle here because I've taught some algebra tiles, and if you're familiar with algebra tiles or you've worked with them before, then that's the shape of variables. But really the goal is to get the variable by itself on one side of the equal sign. Okay, so to put it simply, the goal is to get the variable by itself, whatever the variable is, whatever letter you're using. Now, there is a rule that we have to follow. The rule is what we just talked about with the balance. Whatever you do to one side, you must do the exact same thing to the other side of the equation. Why? Because if you don't, it's no longer balanced. Add the same amount to both sides or subtract the same amount to both sides, or else it's no longer equal. And you have changed the equation. No longer equal. So, goal, get the variable by itself. Rule, whatever you do to one side, you have to do to the other side. So we're going to talk about solving one-step equations, and we're going to talk about just using addition and subtraction today. So to isolate the variable, to get it by itself, we're going to use what's called inverse operations. Inverse is a fancy word for opposite. These are just operations that undo each other. So we're going to subtract to get rid of things from each side. We're going to add to kind of cancel things out on each side. And I'll talk you through what I mean here as we go through examples, but I want you to think of these as opposite operations. Whatever operation I see taking place in the equation, I do the opposite to get rid of that, to cancel it out. Okay. And another really cool thing about equations is when you're done, you can always check your solution by substituting whatever number you got into the original equation and checking to make sure that it's equal. So let's jump right into it. Here we go. X minus 6 equals negative 12. To start, I like to draw a line down the equal sign, just so I know here's the left side of my equation, here's the right side of my equation. Now I said just briefly, opposite operations. Whatever operation I see, I do the opposite. Well, I see subtraction. So the opposite of that would be addition. It was subtracting 6, so the opposite of that would be to add 6. That's how I would get x by itself. Now, whatever I do to this side, my rule says I have to do the exact same thing to this side. So I've added 6 to both sides of the equation. Now I'm going to just draw a horizontal line. I'm just going to kind of total things up. Over here, this was negative 6 plus 6. Well, negative 6 plus 6, that's 0. They just cancel out. So all that's left is x. I'm going to drop down my equal sign on this line. On the right side, it was negative 12 plus 6. Well, I know that my integer operations tell me these are different signs, so I subtract them. Negative 12 plus 6 is negative 6. X is by itself, so here's my solution. X equals negative 6. Now I'm going to show you how to check it. So check, we use the original equation. X minus 6 equals negative 12. And I'm going to actually plug my solution in for x. So where I see x, my solution told me that x was negative 6. So instead of x right here, I'm going to write negative 6. Everything else I'm just going to copy down. So copy down minus 6, copy down my equal sign, copy down the negative 12. Now I no longer have a variable. I just have to evaluate and see if it equals negative 12. Negative 6 minus 6. If I make my 2 marks, I can change that minus 6 into plus negative 6. Negative 6 plus negative 6 is negative 12. And I end up with negative 12 on both sides. Those are equal. So that tells me that my solution is correct. My solution is not negative 12. My solution is negative 6. This just verifies that my solution was correct. Let's try another one. X minus 9 equals negative 3. Again, draw the line down the equal sign so we have plenty of room for our work and it's separated. I see subtraction, so I do the opposite. Opposite of subtracting 9 is adding 9. What I do to one side, I have to do to the other. Now I just kind of evaluate things. Negative 9 plus 9 is 0. These just cancel off. You can even cross them off if you want. Gone. All that's left is this x. Drop down my equal sign. Negative 3 plus 9. These are different signs. Would give me positive 6 because there's more positives than negatives. X is by itself, so my solution is solved. It says x equals 6. Now let's check it. So again, copy the original x. Minus 9 equals negative 3. And now I'm going to substitute. I'm taking this 6 and I'm going to put it where this x is. So instead of x minus 9, it's 6 minus 9 equals negative 3. Now just evaluate. 6 minus 9, that's negative 3. Even though I can see that it is supposed to equal negative 3, I always like to just drop this down and see that I have the same number on both sides. That just verifies it. My answer is x equals 6. One more, and you know what? Let's change this to plus 17 instead of minus 17. So again, draw my line. In the equation, I see plus 17. So I'm going to subtract 17. Opposite of addition is subtraction. Whatever I do to one side, I have to do to the other. Don't get thrown off that the variable's on the right side or that it's c instead of x this time. No big deal. On a balance, doesn't matter what's on each side. An equation doesn't matter which is on the left and which is on the right. So I saw plus 17, so I subtracted 17. I'm going to start on the side with the variable. 17 minus 17 is 0. All that's left is c. Over here, this is negative 23, this is negative 17. You could do negative 23 minus 17, or you could just think of it as an addition problem, negative 23 plus negative 17. Negative plus negative is more negatives. That would be negative 40. C is by itself, so here's my answer. If you would feel better writing it with the C on the left and saying C equals negative 40, you can certainly do that. And now let's check it. Copy the original, negative 23 equals C plus 17. Instead of C plus 17, we're going to change it to negative 40 plus 17. So copy my negative 23. Over here, I just need to evaluate. They're different signs, so I'm going to subtract and get 23, but it's negative because there's more negatives than positives, and I can see negative 23 on both sides tells me, verifies that my answer of negative 40 is correct. So in closing, we're getting closer and closer to solving two-step real-world and mathematical problems and equations using rational numbers. To review, we learned how to solve one-step equations by using inverse or opposite operations. Whatever we see in the equation, we do the opposite. That isolates the variable for us. And then we learned how to check our solution. So this should help you with one-step equations. Have a great day.